Trigonometric integrals. In this session, we will try to integrate trigonometric expressions. And the tool that we need, it will be basically a couple of trigonometric identities plus U substitution. Okay, let's see. Before we start integrating, let's look at a couple of identities, couple of formulas. Pythagorean identity, sine squared plus cosine squared equals to 1. Then when we solved for sine squared, we will have expression in terms of cosine or the other way. And that's me. Please make sure that we are flexible and we may rewrite back and forth. Now, since trigonometric ratios are based on the right triangle is connected to Pythagorean theorem, we like the even powers. And that's mean when we, for instance, we will have higher even power, then we may always rewrite sine or cosine, actually. I can maybe write cosine, but let's say sine the same way. Sine to the power of any even power can be rewrite in terms of cosine. This way, okay? That means we may always focus on the square, the sine to the power of 2, because we will use Pythagorean identity, and the remaining factor. 4 is 2 times 2. 10 is 2 times 5. Of course, this will be maybe a little bit longer, but we will learn in a minute what to do with the cosine or sine square. Yeah, let's maybe, for instance, let's say cosine to the power of 12. Right? We can focus on cosine square and to the power of 6. And if we want cosine in terms of sine, square is the easiest power. 1 minus sine square of x to the power of 6, and we can proceed with this. But this is just showing me how we can rewrite sine in terms of cosine. If we have even powers, it's a little bit more pleasant, okay? Now, double angle formulas. Sine of 2x equals to 2 times sine of single x times cosine of the single angle. Cosine of 2x is a little bit different. Cosine square of x minus sine square of x. You know that formula. Since we see the square, the even power and the square, we may rewrite cosine of 2x in terms of sine only or cosine only. In terms of sine, in terms of cosine. I use Pythagorean identity to replace cosine square of x as a 1 minus sine square of x, and that's the result. And to have the expression in terms of cosine, I rewrite sine square of x in terms of cosine square, and that's the result. Okay, now, that means this is double angle. Now, interesting thing, we may take this double angle formula in terms of sine and in terms of cosine, but the double angle for cosine, okay, we can see it's cosine of 2x, cosine of 2x. One is in terms of sine, one is in terms of cosine. And we may try to solve both of them respectively for sine square of x and then cosine square of x. Let's solve this equation. I will isolate this and I will isolate sine square of x. That means sine square of x can be rewrite as this. 1 minus cosine of 2x over 2. Okay. So we can see, we may rewrite this as the formula above. Now let's do the same for cosine square of x. Let's solve it for cosine square of x. 1 plus cosine of 2x. Please notice that sine formula has cosine of 2x and cosine has also cosine. The only difference is subtraction, addition. And since this is 1x, one single x, and this is double, then that x is half of this, half angle. These formulas are called half angle formulas. But we can see they are based on double angle for cosine. Okay, that's an also important formula for integration, because having square, it will be challenged to integrate sine square of x. In order to integrate sine square of x dx, we will use half angle formula, always. Okay. Now let's see if we understand the half angle formula. just knowing that this is half of this. If you will see 3x, that's half. Then we will have 6. 5x is half, if we're using the half-angle formula, and so on. And that's mean now it looks like you may integrate all of these expressions, cosine square or sine square of an angle, because we will use half-angle. Okay, what else we need? That's the direct, immediate antiderivatives. We just reversing. In case of extra coefficient, we know how this coefficient, it will stay, but we will divide by this coefficient. Yeah? Like ax, we will divide by a. I mean, for instance, integral of cosine of 7x dx, integral of cosine is sine. Integral of cosine 7x will be sine of 7x, the same angle, all over 7. Easy. Okay, and then now let's see what we have in this section. That's mean, as I said, nothing like no complicated, no new integration techniques, just the U substitution and identities, couple of identities, double angle, half angle, and Pythagorean identity. Okay, when you will see a product of sine of x times cosine of x, both of them rise to the certain power. And if the power is even, both of them, n and m, yeah, natural numbers, positive integers, if they are even, we will always apply half-angle identities. For instance, this one, we have just, cosine is missing, but it's just sine square of x. If we see the even power only, yes, only even, then we will use half-angle identities. Sine square of x is equal to 1 minus cosine 2x over 2. And now we can put half outside, and we easily know how to integrate 1. Oh, too fast. How to integrate 1 and how to integrate cosine of 2x. Okay, integral of 1 dx is x. Integral of cosine 2x is sine of 2x over 2. Negative will stay. That's it. One thing that we may do for further application, this is sine of 2x. So we may use the formula to have the answer in terms of single x, single angle. That's mean formula for sine of 2x, double angle, 2 times sine of x cosine of x. And we may simplify, we can divide, and that's and I distribute 1/2. Perfect, that's the final answer. Exercise number 2. We can see the same thing, cosine square of x. Actually, I will just repeat what we did for exercise 1. Instead of subtraction, we will have addition, 1 plus cosine of 2x over 2. Factor out 1/2, integrate 1 and cosine of 2x, using double angle formula for sine of 2x, dividing by 2, I mean 2 and 2 over 2 is 1, and that's the final answer. And distributing 1/2. You may pause the video before you see the solution and try to write it down. I will really recommend and strongly encourage you to write down everything. Not typing, not looking, not meditating, just writing down the solution. Exercise number 3. Oh, too fast. But you can see we have this, we're supposed to sine to the power of 4. Again, just even power. We will still focus on half angle, but we need to see square, because half angle is the square, the second, sine square of cos or cosine square. That's it. I did rewrite this way, and inside I will apply the half angle. Sine square of x equals to this. Now we have to square. Unfortunately, a couple of extra steps. We have to square the numerator and denominator. When we square denominator is 4, 1/4 can be placed outside because it's constant. Now we still have to work on this. But this one is relatively easy. We can FOIL quickly. 1 squared minus 2 times 1 cosine of 2x plus cosine square of 2x. Yes, when you FOIL, you will get this. And now this one, we may integrate is the cosine of 2x. We know what's the integral of cosine of 2x. 2 is a constant. Now we end up having another square. For this one, we will use again half-angle formula, remembering that that angle 2x is half of what we're gonna see. See, that means cosine square of 2x is 1 plus cosine of 4x over 2. I mean, I did apply half angle one more time and thinking and not making the mistake for the half angle. 2x is half of 4. And now easy. Integral of 1, integral. I did distribute 1/4. I mean, everybody can take different steps. Yeah? I did distribute 1/4. 1 times 1/4, 1/4 for this one, because the integral of subtraction and addition is the subtraction addition of these integrals. That's mean 1, but 1/4 is affecting everything. This expression times 1/4, this expression times 1/4, but we have 1/2, then we have 1/8. And now integration. Integral of 1 is x over times 1/4. Integral, oh, actually 2 times 1/4. I supposed to say 1/2. 1/2. Integral of cosine of 2x, sine of 2x over 2. And now integral of 1 is x, integral of cosine 4x, sine of 4x over 4. And we may clean it a little bit, and I believe 1/4 and 1/8 is 3/8 x, and that's, we cannot simplify further. What I supposed to do? Constant of integration. Exercise number 4. Oh, where is my exercise number 4? I have one comment. You may see in the textbooks, in our textbook, reduction formula, but we're not using this. Oh, no, we're not memorizing this. We may just use a common sense Pythagorean identity, half angle or double angle formula, and use substitution in case. But in this case, because it's even, just, we still didn't use the U substitution, but just the half angle, okay, for the even exponent. We definitely, please do not stress out, do not memorize, just common sense. Common sense will come after a couple of hours of practicing. Now, one more with the even. Now we have this typical example for this section. Sine of x times cosine of x, and both of them arise to the power of even number. We still stick to this suggestion. For both of them, we will use half angle formula. Half angle for sine square of x and half angle for cosine square of x. 2 times 2 is 4, 1/4 is outside, and now we have to multiply the numerators. 1 plus cosine of 2x, 1 minus cosine of 2x, 1 plus cosine of 2x. This will give us this, right? Because we know that when we have a minus b, a plus b conjugate, we just squaring the first one, squaring the second, and minus. Okay, that's what I did. Square the first one, square the second, minus. Okay, and we see the square, again, half angle formula. This is half. We have to see 4. Perfect. And now I actually split for 2. We can do this, a little bit of different algebra steps. Negative is affecting both 1 and cosine of 4x. Negative, negative. And now we can integrate. Oh, actually, I did subtract 1 minus 1/2. Well, and now we can integrate. No, still not. 1/2 and 1/2 is a common factor. We can factor out 1/4 times 1/2 is 1/8. Now we have a little bit nicer steps to integrate, no fractions. Integral of 1 dx is x, integral of cosine of 4x, sine of 4x over 4. And we will leave it. I know that I use the double angle, but we don't know the formula for sine of 4x. We may leave it like this, perfectly fine. Okay, that's me. Now let's expand the not only even powers. We're still looking at that example. Now, the exponents, the powers n and m, they could be one even, one odd, either way, or they can be both odd. Okay? If we see, yes, one odd either way or both odds, then we're not using half angle formula. Okay? Now, again, I would like to say just our practice from the U substitution. Now we will just basically apply the U substitution. And either way, yeah, you may try sine of x or you may try cosine of x. Sometimes both works, sometimes not. But we will just, but we can always make the wrong decision. That's I don't want to really, I gave you a couple of instructions and I will follow them, you will see, but just think what works. We know then when we decide that when we make these commitments for the U substitution, we always need derivative for U must be cancel out. That means we have to, pay attention. That means we will just need U substitution and eventually rewrite cosine in terms of sine or sine in terms of cosine. That's it. Yeah, you may think, you may look at this, and then let's apply. Okay. Oh, that's actually nice. Yes, nice and easy. Let me, one second. Why this is, okay. Too fast. Did I change? Because, okay, sine square of x times cosine of x. This one almost nothing to do, but it's one even. Because cosine of x looks like derivative, right? Looks like derivative of sine. And then rest of the integrand is in terms of sine. So what we will do, we will say, actually maybe the u, did I type? Oh no, I didn't type, excellent. U is sine of x because du is sitting and waiting, cosine of x dx, nothing to do. This is du and this is u squared. Little bit too wide. Let's maybe write, we can see how nice du. Okay, u cube over 3. And at the end, instead of u, we will replace u back to the original variable. Done. Really nice. I mean, that cosine was important because this is du. And that's we can see that we don't have to memorize things. Okay, sine square of x, cosine cube. Yeah? One is odd, then we're not applying half angle. Okay, that's now if I see that odd, I can do this one, sine square of x, cosine square of x, that odd number, because we like even. That means I will do this way and single cosine. That means I will again assume that cosine, it will be du. If I want du to be cosine of x dx, then u must be sine of x, kind of backwards. Then the rest of the integrand, except that box is waiting to be cancelled out. This green part, we have to rewrite in terms of sine. It means sine square will stay, and we like square, we like the even, Pythagorean identity. Cosine square is 1 minus sine square of x. Done. And I will keep this. Let's apply the substitution. Sine, u is sine of x, u squared, 1 minus u squared, and this is du. Everything in u. We know that when we make this decision that we're doing the u substitution, we're not allowed to put u and x together in the integrand. Because then it's confusing, unless it's two variables function. We always have to rewrite everything in terms of a new variable. Okay, let's distribute u squared minus u to the power of 4. Integrating u cube over 3, u to the power of 5 over 5 plus the constant, and that's it. Let's say 1/3, replacing u with the original function. U is sine of x cube, sine of x to the power of 5, actually. Okay. Excellent. Exercise number 7. Oh, I don't have exercise number 7. I have exercise number 8. Cosine cube. Interesting. No sine, but still odd power. I will do the same. 2 and 1. Cosine square of x, cosine of x, dx. And this is the single one, not really going along with the Pythagorean identity because we like the even. This will be du. And then the rest of the integrand, rest of the formula, we have to rewrite in terms of sine. And we just learn this. Cosine of x dx. Good. This means u is sine of x, the same thing actually. And this is derivative cosine of x dx. We're not solving for dx. That's not. Okay, 1 minus u squared and perfectly waiting cosine of x dx. Cosine of x dx is du. Integral of 1 is u. Integral of 1 du is u. Integral of u squared is u cubed over 3. And done. Replacing sine of x, sine cube of x. We can see nothing new, nothing new. Oh, okay, that's how we will deal with sine and cosine. Now, surprise, we have another type that we're supposed to look at this, in this section. And again, it's just the u substitution, okay? Almost no formulas. Tangent of x times secant of x. Tangent of x times secant of x, both of them rise to different power, positive integers, and natural numbers, n and m. And we may have two cases. Both of them could be even, both of them could be odd. If one is even, one is odd, then you can decide. You may go this way or you may go this way. Sometimes both works. Sometimes actually none of the way works, but we can always find out. Right? But let's actually see what we can do. If both exponents are even, you may like remember, but even if you don't remember, we have only two options. U substitution. U could be tangent of x or U could be secant. But if both of is even, tangent, the substitution tangent works well. If both of the exponents are odd, secant works well. Because you can see everything is related to the derivative. Derivative of tangent is secant square. That means the even exponent will help. Derivative of secant is secant times tangent. Odd, yes, odd values. Secant to the power of 1, tangent to the power of 1. Okay, one extra thing. If we decided to do this, we will most likely be forced to rewrite secant in terms of tangent or tangent in terms of secant. I mean, this is another version of Pythagorean identity, because 1 plus tangent square of x is secant square, and then we're solving for tangent, secant square minus 1. Okay, just thinking about u substitution, tangent or secant, and this identity. Let's see. Oh, both even. Then we know that we will do, actually we don't even have to think about this. If u is tangent, you will not even, please do not even like memorize, just think. We see tangent, derivative of tangent is secant square of x dx. Then this is u squared and this is du. Done. U cubed over 3, replacing u with tangent cube of x. I mean, I don't even have to like make the statements, two evens and tangent, just common sense. Okay. Oh, 6 and 4, 2 even, okay. But if it's 2 even, we know that we want that derivative secant squared. That's now I will rewrite this. Okay, tangent to the power of 6, secant squared, and another secant squared dx. But this one is reserved to be du. I can even say this. Du is secant square of x dx. Then u must be tangent. But that entire part of the integrand must be rewrite in terms of tangent. So we happy with tangent to the power of 6, we're not happy with secant. And this is our potential du. Okay, secant square of x, we like secant, Pythagorean identity. Secant square of x is 1 plus tan square. That is the moment that we're using this. And now everything we may rewrite in terms of u. Tangent of x is u to the power of 6, u to the power of 2, and this is du. Excellent. Let's distribute u to the power of 6, u to the power of 8. We're adding exponents when we multiply. And we're done. U to the power of 7 over 7, 9 over 9, and replacing u with tangent. Tangent to the power of 7, tangent of x to the power of 9. One more time, I will recommend to do what I did, writing down. And it will stay, you will retain your knowledge stronger, longer. Okay, exercise number 11. Oh, odd, 5 and 3, 5 and 3. That's in odd, we will never, even if I will decide to change this for the square and keep the secant square, it will be not easy to rewrite tangent to the power of 5 in terms of, tangent to the power of 5 will be okay because tangent will be u, but this one will be 2 and 1, secant of x in terms of tangent. Some square root will be involved. That means, no. What we will do, I will actually pull out one tangent, one secant. So what we will have, I will keep it this one, 4, and I will keep square. But now, one secant, actually not sine. One secant from here and one tangent, secant of x times tangent of x. I am pulling out outside, integrand, and we may guess this will be du. Derivative of secant, then the rest of the integrand must be rewrite in terms of secant. Oh, I don't know if I like the fourth, but okay. Okay, in terms of secant, that means secant is fine. Tangent square, we always make the fundamental square, n square. Secant, and I can copy secant times tangent, because my plan is to have the u substitution secant. Okay, tangent square is secant square of x minus 1, and still squared. Okay, and then one more time. You may also do the same. It takes a couple of seconds, but it's organizing the solutions. It's beautiful solutions. Okay, now we're ready because the entire integrand is in terms of secant, and actually that part of the integrand is waiting to be cancelled out, du. Okay, that means u is secant of x, du is derivative, secant x tan x dx. This is our u substitution, and let's see. U squared minus 1 squared, u squared, and this is du. Okay, first of all, let's square it. U squared minus 1. It will be u to the power of 4, 2 times u squared plus 1, and still multiplying each term by u squared. Just distributing u squared times u to the power of 4, u squared times u squared is this, and times 1 is this. Okay, now integration. U to the power of 7 over 7, u to the power of 5 over 5, u to the power of 3 over 3 plus the constant. Now we have to replace u with secant. Can I squeeze this? 1/7 secant to the power of 7, 2/5 secant to the power of 5, 1/3 secant cube of x plus the constant of integration. Excellent. Okay. If this session is too long, you may pause the video, you may go and get a cup of coffee, maybe a cup of tea, or maybe just stretch and come back and finish the integration. Okay, good practice. What else? Oh, multiple choice. Tangent secant. Looks like both are odd. That means I will pull out one tangent and secant square. Secant of x times tangent of x dx. You can see I did rearrange. We know what I'm doing now by now. And if, oh, actually nothing. If u is secant, this is u squared, this is du. If u is secant of x and du is sitting in the box, secant tangent. Okay, perfect. And integration and replacing secant cube. This is the final answer, and I don't know which one works. I hope one of them will work. Okay, but please practice. Okay, another one. Oh, this one is interesting because one is even, one is odd. Okay, the 4 and 3, the powers. And theoretically, I didn't really cover this because I gave you some instructions for both odd, both even. But we remember now you can play. And I will guess that both works, both u substitution will work. You may let u to be secant or you may let u to be tangent. Okay, I will do one method and you may even pick another one for practicing. What I will do, which one will be easier? If I will decide that u is tangent, then I need secant square. Yeah, maybe let's do this one because that's higher power, but either way, that means I will keep secant square of x, tangent cube. Oh, actually it's theta. Yeah, I got used to theta. And what I need secant square theta d theta. That means this is my du. That means I split this. Then this integrand must be, we have to rewrite in terms of tangent. Secant square is 1 plus tangent square. Tangent cube may stay, and this is derivative. It's still part of the integrand. Okay, that means we decided to do tangent. Tangent theta, derivative is secant square theta d theta. Okay. 1 plus tangent is u squared, u cube, and this is du, secant square theta d theta. Let's distribute u cube plus u to the power of 5. We adding exponents. Let's integrate to the power of, am I right? 4 and 6. Okay, I will just, and actually not plus the constant c. Let's find a new limits of integration. Right? New limits of integration, or I can say new bounds. If we applying u substitution with the definite integral, we will need a new u value. Okay, that means x was 0. We can see this is 0. Then the new u value will be tangent of 0, because that was the substitution. And tangent of 0, everybody knows that is 0. That means theoretically it's the same number, but it's actually new. That's why I can say 0, 0. Okay, now when x is pi over 4, then corresponding u value is tangent of pi over 4, 45. It is 1. The best limits that we can get, 0 and 1. What I'm doing? Oh no, I need blue, 0, 1, 0, 1, 0, 1. Okay, and then I don't have to. Okay. Fundamental theorem of calculus, substituting upper limit and substituting lower limit will give us 0. 1/4 and 1/6, I don't know. We may say 10/24, but 12 actually. 12 actually is the common factor, the lowest common factor. I did 24 because I just multiply, but that's, you can get faster than me. I know that. Okay. And again, if the session is too long, you may take a break, but I have 2 more, I think. Okay, secant square and cosine cube. I will actually leave this one for you. Okay, you may figure out, maybe u is sine of theta, maybe u is cosine of theta. You will figure out. Okay, that means this will be the last one. It's really nice integral, doesn't really match to our type of the integrals. Because it was sine times cosine, secant times tangent, but we may still think about the method, the algorithm. Yeah, so I'm giving this example because even if it's doesn't look standard, doesn't look the same, yeah, you can still think, I know how to solve that problem. Yeah, the same in our life. We will have problems and we may apply algorithm that we solve another problems. Okay. So what I can do, I can maybe do secant square. Okay, this is, of course, that's weird, tangent. Secant square times secant square of x dx. And that 4, that power 4, I rewrite as a secant square times secant square. Now, since I am already, you can see, boxing, separating secant square, then I'm trying to this will be the derivative, secant square of x, and derivative is for tangent of x derivative. That's mean now, since I make this commitment to have, u substitution, what's going on? U is tangent of x, derivative is secant, then that expression, except this secant square of x dx, has to be rewrite in terms of tangent. So we can leave it this one, that's good. And secant square is square, it's nice. Secant square is just 1 plus tan square of x. And this is secant square of x dx. Okay, so we have u is tangent of x. Maybe the other way, tangent of x is u. 1 plus u squared over square root of u, and this is t. 1 over square root of u, u squared over square root of u, du. This is u to the negative half. This one will be 2 minus half, 3 halves. Okay, integral of u to the negative half is u to the power of 1/2 over 1/2 is this. U to the power of 3 halves, the integral is u to the power of 5 halves over 5 halves. Dividing by 5 halves is multiplying by the reciprocal. Okay, but yeah, let's actually rewrite a little bit nicer. U will be definitely replaced with tangent of x, and u to the power of 5/2 is square root of u to the power of 5. Square root of u to the power of 5, and u is tangent. That's a little bit more consistent, because I did write, maybe I can write u to the power of 1/2, just to be consistent with my form, exponent form, I mean power form, and then root form. Okay, now I think we can finish the session. If you can solve all of these problems, you will be great. Keep integrating. Thank you.